Okay, this is the beginning of lesson 3.4 in MyOpenMath, and the first couple questions are open-ended type, and they ask us to find the domain of f over g, the quotient. Well, we first have to find the domain of f, and we have to find the domain of g, and then we look at where g of x cannot equal 0, because we cannot have any value of x that makes the denominator equal to 0. Alright, so to find the domain of f and g separately such that g of x does not equal 0. And if you have a square root or something in f, then you have to obey those rules separately. So we take the domain separately of f and separately of g and just make sure the denominator has no values of x that equal 0. Now, we're asked to find the domain of f of g. These are called composition questions, and they use this little symbol, and that word means of. So the way you read this is f of g of x, okay? And what that basically means is we put x into g first, get an answer, and then put that answer into the f function. That's what that basically means. So to find the domain, what possible values of x we could have, we find the domain we start with g, find the domain of g, okay, and then we find what values of g in the domain are also in the domain of f. And we include all those values that are in the domain of f. So anything that's not in the domain of f, we exclude. So we start with the variable closest to the variable, start with the function closest to the variable, in this case g, find the domain of g, and then we look for values in the domain of g that are also in the domain of f. Alright, so this sounds like a lot of mumbo jumbo, so we're going to take a numerical example right here, where it says f of g and g of f. Now, they're usually not the same. Could they be the same? And if so, when? Well, I'm going to answer that question right now. We're going to find f of g of 2 and g of f of 2. So what does that mean? That means we put 3 into g, so we put 3 into g, and we get, actually 2 into g. We get 2 minus 3 over 1, so that's going to be negative 1/2. And then we take negative 1/2 and we put that into f. Well, f is right here. So we put negative 1/2 into there, and we're going to get negative 1/2 times 2 plus 3. So that's going to be negative 1 plus 3, so that's going to be 2. So when we did f of g of 2, we got an answer of 2. Now we're going to do g of f of 2. So we do that, we put 2 into f. F is over here. So we're going to get 2 times 2 plus 3, and we're going to get 7. And then we put 7 into g. So what does g tell us to do? Well, we do 7 minus 3 over 2, and we get 4 over 2, which is 2. So in this particular case, I made this special. F of g of x and g of f of x are both equal to 2. That's a very rare case, and if that ever happens, that means that f and g are inverses of each other. Okay, that's a key open-ended question I like to ask on exams. So they are inverses of each other. So if f of g and if f of g and g of f are the same answer both ways in both orders, they are inverses of each other, and they're usually not. Okay, the next couple of problems here, we're given two functions, f of x and g of x, and we're asked to perform these operations. So f of 3 plus g of 7, that means we put 3 in here, and we put 7 in here, and we find our answer. So we're going to get 9 minus 4, so that part's 5, and we add 5 too, so that means we get two separate answers, and we add those two answers together. So we put 7 in here, and we're going to get 8 times 49 plus 35 plus 13. We're going to get a really big answer for that. So 8 times 50 is 400. 400 minus 8 is 392 plus 35 plus 13. So we get whatever that answer is, we add that all together. It's going to be 38. So it's going to be 430 plus 5 is 435. Put those all together. Now, g of 6 minus f of 10, so we put 6 in here. So that's going to be 8 times 6 squared plus 5 times 6 plus 13. You get that answer, whatever that is, and then you subtract off whatever f of 10 is. F of 10 is going to be 3 times 10 minus 4, so that's going to give you 26. So you get this answer, use your calculator if you need to, and then subtract off 26, and that'll be your answer. Now f of g times g of 12, sorry, f of 9. F of 9, you put 9 in there, and we're going to get, what's that? What's 3x minus 4, as you can see? So it's going to be 9, 27 minus 4, so it's 23. You get an answer for that. Then you multiply it times the answer you get from G when you put a 12 in there. That's a huge number. So that's going to be times whatever you get here. So it's going to be 8 times 12 squared plus 5 times 12 plus 13. So be careful here to use the exponent here rule. You're going to get 144, and then you multiply times the 8. That's a problem that some people make, so be careful of that. And down here they ask us to find g of 11 divided by g of 6. So g of 11, you put 11 in there, you're going to get 8 times 11 squared plus 55 plus 13. You get that answer. You put that over f of 6. So that's going to be, f of 6 is going to be 18 minus 4, so it's going to be 14. So you can type that answer in the box. So you just get two separate answers and perform the operation with those two answers. Now down here we have three different functions defined, and we're just asked to perform operations with them. Now notice you're not going to get a numerical answer. You're going to have x's in your answer. That's okay. Alright, so g of x plus h of x, that means we take g of x, which is x plus 9, and we simply add that to h of x, which is 3x squared plus 22x minus 45, and we combine like terms if possible. So if we do that, we're going to get 3x squared, we x plus 22x, so that's going to be 23x, and then 9 minus 45, so we're going to get minus 36. So all you're doing there is combining those terms, those two functions together. Now this is h minus g. So be careful with the order here, and be careful with the minus signs. So we have, that's h of x, and we're going to subtract g of x. I definitely recommend you put parentheses around that, and then when you do that, you open up the parentheses. That means this negative changes to both signs. So that means when you get to here, this negative is distributed to both terms. It's going to be minus x and minus 9. So be careful with the minus signs. Make sure you have the right order. So it's going to be 3x squared, and you're going to get plus 21x, and then minus 54. So be careful with that. And then f of x times g of x. Well, f of x, f of x times h of x. Well, f of x is going to be negative 2x. And h of x is this big messy problem over here, function. So we're going to multiply that out, and we'll get negative 6x to the third minus 54x squared minus 90x. And that'll be f of x times h of x. And the last one here is h of x divided by g of x. Well, h of x is 3x squared plus 22x minus 45. And we just divide that by g of x, which is x plus 9. Now, we're not asked to carry that out at this time, just to write out what it would be. But don't worry about anything more than that. You don't have to do any other calculation at this point. Now, in this problem, number 5, that asks you what's the domain restriction of g of x over f of x. Well, f of x is negative 2x, so x could be anything here, so there is no domain restriction. No domain restriction here. Now, the only time you have domain restriction, don't forget, is when you have, take that back. You can't have, this happens to me in the denominators. Normally, it could be any real number, but take that back. But this is in the denominator, so that means that you cannot have 0 in the denominator. So the domain restriction is x cannot equal 0, because you cannot have, we cannot have f of x equal to 0. So let's look at the function. The function says negative 2x. So negative 2x cannot equal 0. So that means that x cannot equal 0. And that's all we can do for that problem. Okay, in this problem, we're looking to find f times g of x. Now notice that's a dot, a solid dot, not a hollow one. So that is multiplication, not composition, okay? That means we get two separate answers and we multiply. Okay, so this means we get f of x times g of x. So that means you take 5x plus 4 and we multiply it times 3x plus 1. So that's going to be 15x squared plus 5x plus 12x plus 4. Combine middle terms and we get 15x squared plus 17x plus 4. Now notice this does not equal f of g of x. These are not the same. This would mean you take the answer for this one and put that into the other function. That's not the same thing. This is a graphical problem from MyOpenMath. Definitely a distinct problem, so I wanted to show it to you the way it appears. It asks for f of 5 plus g of 4. Well, f is on the left and g is on the right. So f of 5 is right here. You go to 5. That's the x value. You find the y value that goes with that, and that's 4. So I'm going to have an answer of 4 on the left here. And then I add that to whatever I get for g of 4. Now, g of 4, this is g on the right here. So g of 4, you go to the x value of g, you go up to 4, and you get to y value of 2. So on the top left, you're going to get 4 plus 2, which is going to be 6. Now, on the bottom left here, it says f of 5 times g of 3. So f of 5, this is f. f of 5 is going to be 4. And then times g of 3. Well, g over here is 3, so x, you go up to the y value, and it's 4. So you're going to get 4 times 4, and you're going to get 16 down here. Now, on the top right, you're going to get g of 3 minus f of 2. Well, g of 3, go over to x equals 3. G of 3 is equal to 4 minus f of 2. I'm doing this problem right here. F of 2, you go to 2, and you get 2 for y also. So it's going to be 4 minus 2, which is 2. Now, on the bottom here, you have g of 4 over f of 2. So g of 4 is going to equal 2. And you divide that by f of 2. F of 2 is 2. So you have 2 divided by 2, and you get 1. So that's how you handle a graphical problem like that. Okay, a couple more problems here. This is f of g of x, not multiplication. We have the dot there. So we start with the function closest to the variable, which is g, which is this one over here. So we put that in to f, where x is. So this is our input right here. So g is our input into f. So f says 2 times my input plus 4. So the input in this case is that whole function, 4x squared plus 2x, because that's my g of x. So we put g of x into f of x in place of x. So we're going to get 8x squared plus 4x plus 4. And we're done with that one. Now move on here, we're going to do f of g of x. We call those fog and Goff problems. So we take g of x and we put that into f. So we put g of x into where x goes. So it's 7 times x squared minus 7x plus 3 minus 7. We're going to get 7x squared minus 49x plus 21 minus 7. So simplify, and we get 7x squared minus 49x plus 14. And we're done with that one. Now we'll do the Goff. No, that's the opposite order, so it's probably not the same. We take f of x and we put that into g. So f of x is right here. That's the whole thing. And that goes in place of g. That's a much larger problem. So that means we take 7x minus 7, square it, subtract 7 times 7x minus 7. So in place of x, I'm putting 7x minus 7 plus 3. So we have to multiply that out. It's going to be 49x squared minus 49x minus 98x plus 49 minus 49x plus 49, because you have to multiply this out, okay, plus 3. So we simplify that all together, and we should get 49x squared. Now we have minus 98x minus 49x. That's going to be minus 147x, okay. Then we have plus 49, which is plus 98 plus 3. We simplify that to plus 101. Okay, so that's our final answer right there. All right, a couple quick ones. F of g of negative 1, so you put negative 1 into g, and we get f of 1, negative 1 to g, and we get 1, and then you put that answer 1 into f. So it's going to be 1 minus 2, so it's going to be negative 1. Now we do g of f of negative 1, so we put negative 1 into f right here, and we get 1 plus 2, which is 3, and then we put 3 into g, which is 3 plus 2, which equals 5. Okay, the last problem of this video is the domain of f of g of x. Now it's a little more complicated. So g of x is right here. Well, the first thing we have to notice is that x cannot equal 0, okay? So it has to obey both of these rules. So we have to obey the domain of f of x and g of x. And therefore, when you go in here, whatever this is, x cannot equal 8. So therefore, 9 over x plus 3 cannot equal 8, which means 9 over x cannot equal 5, which means we have 5x equals 9, so if x cannot equal 9/5, that's the other part of the domain.